Very proud and good. I got the YouTube stream up. I'll probably start the stream by looking at some E&M. I'm doing good. How about you, Hayden? My issue this entire week is I tried to read this book, but I'm doing it like in bed as I'm falling asleep, and I've been falling asleep like instantly. I don't think I've gotten more than a few paragraphs in before I fall asleep with my phone in my hand. You don't know? Okay. Fair. You don't have to know. I do remember being weirded out by this figure because it looks like some kind of like... These look like cells in a petri dish. Yeah, my sleep schedule's actually been pretty good like this week. So I'm not complaining about falling asleep quick, but it's cutting into my usual like studying time, which I don't know why I would study when I'm in bed trying to fall asleep, but oh, is your sleep schedule not good right now, Waffle? Oh, what argument is this gonna make? What the hell? Hmm. If you can get sleep, that's fair. What? Oh, that okay. I was wondering why this made no sense. It's because the right part was cut off. Hmm. Okay. I've been waking up before my alarms, which is kind of crazy to me. See, usually I have many alarms set in the morning and I still manage to sleep through them. Hey, Joseph. Good to have you. Best Twitch streamer ever. Thank you, Hayden. I could make my stream so much better. I'm just too like tired when I'm off stream to actually like put in the work. So it's like maybe not like so much better, but like there's a lot of things that I wanted that I just like haven't. Oh, nice, Joseph. When I'm off stream, I usually have, you know, friend streams open. And it's sometimes like my Firefox kind of starts to hate me after I open up like more than 5 streams. It's a little ridiculous. Surpass case. All right, just give me like 20 years, and I might have like a 1% chance. What are they gonna do with this? Not in Big Macs, I don't think even Galactus can do that. I don't know what that means. And I know who Galactus is, that he's like in the MC, right? Like a giant, he's the guy who eats galaxies. Yeah, trucking. In terms of the technology, Twitch is pretty bad compared to YouTube, but the community on Twitch is really good. Oh, in terms of Big Macs eaten, yeah, I don't eat Big Macs. Unless I'm, the only time I would eat McDonald's is if I'm on like a road trip and it was like the best thing around. OBS hurts my soul so bad. Twitch View is okay, really? I never tried it, but I just assume that it's bad if Twitch makes it. Vincent Van Doe. Oh, that's what they're doing? They get a system of equations out of this? Oh, I guess that makes sense. They shut it down? Oh. I don't think that thing was around for very long then. Oh, I think that's what Dan would use. I wonder what he's gonna do if and when he comes back. Yeah, that's fair. I mean, even though OBS has its flaws, it's open source, it's completely free, there's lots of plugins for it. I think it's kind of hard to beat. Just trying to make it work sometimes is the issue. The chat overlay was super easy. I did it through Stream Elements. This is what I use for like the chat overlay, the alerts, donations. I have in this like overlays thing here. Oh yeah, okay. How TF this work is my alerts. The math chat is the chat up there because and these are all like they're just browser sources that you add. Like you get an actual like URL that you can add as a browser source in OBS. It's a little annoying to work with this, but like just for a chat, it's pretty easy. You just have like this is like a 1080p like canvas here, and you literally just have like a bunch of like widgets down there that you can add. So, and I think for stream elements, you only need to have a certain number of followers, like 100 or something, and that's all you need to qualify for it. It might even be 50. I don't know. But yeah, so this actually, like, it uses OBS very little. All OBS does is it has a browser source. Like, you copy the overlay URL, you just hit that button and you paste it into OBS. Oh, really? Yeah, I didn't even think about getting the link for the pop-out chat. But, stream elements... gonna replace it right with the chalkboard. Zach, thank you very much. Bitch. Welcome in, everyone. I was lurking. It's like you're having some good conversations. We were just talking about how to set up a little Twitch chat overlay there. That's how I did do it. So I was just showing how I did in Stream Elements. Hey, oh wait, Joseph, I already said. I'll say hi to you again, Joseph. Welcome in. But yeah. And thank you for doing that. For looking at that problem that was posted in my Discord. I had no clue how to do it, so I appreciate you looking at it. Is that for the first time yesterday, Dr. Cook? Yeah. It's Shimon's is a little bit weird, but it definitely works. That's our yeah. Oh yeah, $10 told me that you know Dr. Morin. So we've been I've been doing a reading group on Saturdays for E&M. And hopefully on Saturday we're going to be talking about chapter 3 for the first time. Me and Morin are homies. Oh, that's awesome. But yeah, I'm trying to get through chapter 3. It's been none of these chapters have been easy, but each one has been harder than the last. So chapter 3's been a little rough. But the math that goes on in this it's so much fun. I absolutely love using the calculus. Like it's not an easy book. Yeah. Where is it? Like I'm gonna keep coming back to this. This is like my favorite graphic so far in the entire book. I just love how like I really wish that I was taught, you know, maybe not this intensely, but something like this in my multivariable calculus class to actually know like why the hell the things I'm learning there were actually helpful. And it's just so cool how everything is connected in this way. Yeah, Fembox. Oh, okay, we got a question in the YouTube chat from Pretam. For any quadrilateral ABCD, which of the following statements are true? Oh, there might be more options to that coming. I'll copy over that first part to the Twitch chat. So it seems like a 1, 2, 3, maybe 4 question, and you have to choose which combination of those. Which those questions seem if they're not constructed right, they seem kind of flawed to me, but. Yeah, we were thinking about doing the Griffiths book too, but I asked physics and depression for recommendations on books, and it was those two that he said. But the thing that like made me more interested in this one at least is apparently I think magnetism is introduced as an effect of relativity or something like that. And I've never studied relativity before, but learning about it seems like a cool opportunity. Hey, Quam. All right, so Kiranjit in YouTube chat as well. I see your question too. That's, oh gosh. I don't exactly how to do that one off the top of my head, but there's a question before that from Pretam that I'm going to work on first. Pretam, are those the only two options, or are there more options that maybe got cut off by YouTube? Just E in a different frame? Oh, interesting. Hey, Thunder. Only two options? Oh, okay. Thanks for clarifying that. Any quadrilateral. I don't know that I need to draw a picture here, I guess. Sounds good, Kiranjit. So what's like the scalene triangle equivalent of a quadrilateral? Okay, can you have like all four angles different and all four sides different? Is that possible for a quadrilateral? I just drew a trapezoid, I think. uh, I don't know if that's even a valid shape. You think Finlux is saying one is true, two is false? Okay. Hey, it's PQ. And Qualcomm, thanks for the follow. Yeah, I'm interpreting ABCD as angles. It looks like a parallelogram, but I don't know how better to do it. So our options are what? Sine of A plus B sine of C plus D is 0. So it's either, okay. I assume these can't simultaneously be 0 at the same time, right? Sine and cosine, unless there's some kind of cancellation, maybe. I wonder if trig identities would help clarify this. Like, what do we know about this? Make sure I'm copying the angles. Right. Yeah, okay. (180 plus alpha, 180 minus alpha is 0. That's a trig identity that you're saying? Ah. That makes sense, I think. I don't quite know how we use it yet. But what do you know about the angles in quadrilaterals? Do two adjacent angles, I assume they have to add up to more than 90? That's probably accurate to say. You couldn't have... Ooh. No, maybe not. You could have that. These two angles wouldn't add up to more than 90. Okay. I thought we would get opposite angles, which for some reason feels easier for me to work with, but... A square? Oh yeah, maybe looking for counterexamples is a good idea, SPQ, rather than trying to do this generally. So if we do take a square, you would have sine of 180 plus sine of 180 equals -2, which is not 0. Okay, so that's a great call, SPQ. I think we can tell the first one is wrong. Does this check out for cosine? Yeah, it does, because cosine is 0 here. Doesn't mean that cosine has to be true on its own. This equation isn't necessarily true. Oh, Cyclone Edicts. You know linear equations in two variables? Depends on what you're trying to do with it, but if you're just trying to solve simple equations, I can certainly do that. If you're trying to like graph a three-dimensional line, I can do that. I'm not sure. Oh, do I not know the unit circle? Sine of pi. Oh no, wait. Oh my, I got that reversed? Can you solve some AMC problems on AOPS, Qualcomm? Sorry, but no. I have zero interest in solving competition type problems like that. Cyclone, I feel like I just addressed you and you just pasted your question again. Like, it depends what you're trying to do with it. If you want to put the actual question, I can tell you yes or no, but I probably can. Yeah, so I don't know the unit circle. Evidently. So that means that the square is the counterexample to the cosine one then, is it not? Yeah, Qualcomm, that means if you give me a problem, I promise you I can walk away from it. If you give me a problem, I'll not solve it. I can promise you that. I'm going to blame that I'm using degrees here, not radians. I'm getting that mixed up. But anyway. Oh, SB, you would have said it's a counterexample to 2, and I just read that 2 as a 1. Hey, Banana God. A plus B be alpha. Sine of alpha. Oh, true. The angles add up to 360. Okay, yeah. Well, let's try that approach at SPQ. So actually, wait, yeah, do we... I don't actually know exactly how to apply Fenvox's thing. It does seem helpful. I still don't know exactly how you apply that, but... Actually, how do you apply the 360 thing? Oh, I think I see. Okay, yeah. Okay, so we know the angles in a quadrilateral add up to 360 degrees. And if we rearrange this to solve for a plus b, just arbitrarily because we have an a plus b there, we can say that a plus b is the same as, well, no. It doesn't matter which pair you solve for. I'm going to subtract a and b over, and get c plus d to be isolated and plug it in from right down there. Minus a minus b. So I'm going to take this relationship here and plug it in here. Now, what's significant is that the period of sine is 360 degrees. And so I think we have the relationship that sine of 360 minus something is the same thing as sine of that thing. So sine of 360 degrees minus x, I think we're going to say is the same thing as sine of x. And I think that checks out. So there's a little trick here where I need to, well, wait, no, we want it to be negative if this thing is true, do we not? I assume it's a sign of negative x if this thing actually works here. Oh, okay. So, pretend this particular thing with sine always trips me up. The same thing is true with cosine. What we're finding here is that this blue curve is the graph of sine. And if we take sine of 2 pi minus a thing, we get negative sine. Like it's just like flipped vertically. Which always... I can never figure out if we want the minus sign or not, is my issue with working this out. But regardless, I'm going to do one rewriting step before I apply this identity, which is sine of a, oops, plus b plus sine of 360 degrees minus, I'm just going to factor the negative sign out from the a minus b. And I'm doing that to make sure I don't lose track of the signs, of the negative signs, not of the sine function. So now this thing exactly matches 360 minus x because we have 360 minus a thing. When we have a minus minus, it's not necessarily quite so clear what's happening. So now I'm going to apply this identity here in red. We get negative sine of x, but our x here is a plus b. And look at that, sine of a plus b minus sine of a plus b, that's 0. 0 equals 0, this thing is always true. So I'd say that 1 is always true, 2 is not always true. I don't know if it's always wrong, but it's not always true at least. So that makes sense pre-Tim. So let's look at Karanjit's question, which also has to do with trig functions. I've done problems just like this before. I don't remember... There was some pattern with half angles, I think. All right, I've done very similar problems. Not this exact one, I don't think, though. You want everything to be with cotangent of 1 degree. Cotangent is sine over cosine. Twitch turning that into an emote. 2 holds if and only if cosine a plus b is 0. Oh, sure. Using that same angle thing. But you, in a quadrilateral, you can never have a plus, or, well, wait. Where's cosine is 0 at 90 degrees. So if they add to a 90-degree angle or to 70-degree, okay, fair. Oh, you know what? The way that I should have been thinking about the 360 minus thing is I should have thought about it as negative x plus 360, and that makes how you use the periodicity like way more obvious to me. When it's 360 minus x, I get lost in the function transformations, but if you just rearrange the order to be negative x plus 360, then it's like, oh yeah, of course. What the heck is up with... We need to, in some kind of smart way, apply probably that sine identity. Like this one. So we should be able to figure out a pattern with powers of 2 are going to crop up. And we can get them all to be in terms of sine of 1 times cosine of 1, and hopefully something magical happens there is my only idea. So let me write the identity that we're going to use on the board. Then we have 2 sine 2 degrees. Got ahead of myself. I tried to write the degrees symbol, but I hadn't written the 2 yet, so I did them both at the same time, apparently. So what's this pattern? 2 sine 2, 4 sine 4, 6 sine 6. Oh, it's every even number. Ugh. Sorry, 90 cotangent 1. Cool. Can't write. Okay. So what's going to happen here? If we apply the identity up here to this, we're going to get a 4 sine 1 degree cosine 1 degree. We would apply it twice to this one. How does this work? I just want to write this first one out at least. 4 times 2 sine 2 cosine 2. Oh my god, I did it again. Oh, what do you do with the cosine? That's the problem. The sine 2 we can deal with. The cosine 2. You know, I just can't please you, can I? When I'm playing Daisy, I'm not doing math. When I'm doing math, I can't. Never. Never, you and your international keyboard. Um, guessing you might also use some difference identity to get pairs where theta and phi add to 180. Oh. That's a thought. Oh, God, Joseph. Yeah, I mean, I'll work on it when there's like dead time, I guess. Hmm. Okay, yeah, so I forgot that this extra cosine of 2 degrees would pop up here. We need a way to deal with that. So we could do one of these. Oops, I'm not clicked in. But this looks terrible. All of these. Once you get into, like, you know, cosine 90, you're getting a lot of these. Well, we probably won that last term for something. That's my bet. There's also a sign of 90 in there that you could like, you know, evaluate if you wanted, but yeah, Karanji, that's what we were just talking about, but we might want that to be 180 sine of 180 for some type of identity. Like, we might not want to simplify it yet. Oh, that's interesting, Dr. Cook. Yeah, I don't think we want to do a double angle on that cosine. We do have... Oh, do we want to use that same identity as in the last problem? Like, you're saying to rate on trade identities? Oh, okay. We could do... sine of pi minus x equals sine of x. Because we do get pairs. We have 2 degrees over here. On the right side, I'm going to break out some more of the series here. So 2 degrees would go with 178. 6 degrees is going to go with 174. So we might want to evaluate that sine of 180 to be 0 at some point. I'm still going to keep it unsimplified just for now, though. But we are able to pair up the 6 sine 6 with that, the 4 sine 4 with that, and the 2 sine 2 with that, using this identity. And the one that'll get left untouched is the 90 sine of 90, which won't have a pair. But we know the value of that. So 174 is sine 174. The 174 up front stays the same. Using this identity up here, that sine 174 is equal to sine of 6. So that cuts the sum, like the length of the sum in half, I guess. And so what we can do now is add the 2 degrees, 4 with 4, 6 with 6, and they all add to 180. So we get 180 sine of 2 degrees plus 180 sine of 4 degrees plus 180 sine of 6 degrees plus dot 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 plus 90 sine 90 plus 180 sine 180, which you probably can safely just evaluate the sine of 180 now, and probably even the sine of 90. Let me catch up with chat. Okay, Karanji. Okay, I'm glad that we're on the right track then with using that identity. And hey, Numplex, I'm doing well. How about you? And SKK, baby? I don't know. EII matrix? If AB equals BA, then A is equal to A inverse? I bet there's some neat way you can prove that. I don't... Shoot. I don't immediately see how you would prove that, though. I don't know what an EI matrix is, though, I guess. If someone is interested in cryptography in the cybersecurity field, what kind of math should they be learning? I bet the number, I don't know exactly. The person who could speak to this the best is Penn Center. He'll be streaming tonight. So I bet Penn Center can give you a much better answer than I can, but I think number theory is a big one, probably a little bit like linear algebra. Hey, Yanis. But I imagine that number theory is your biggest one. And hey, Albedo, factor out the 180. Oh, no, I usually they don't want you to use complex variables here. It's probably easier, but I don't imagine the person who's working like Karanji over in YouTube chat is supposed to use complex variables. I bet that is the easiest way, but it's usually not something that you're expected to be able to use for a problem like this, I feel like. Sine of 180 is 0. Sine of 90 is 1. We have to end up with cotangent here, which is kind of confusing. Like, when do we probably want to multiply by cosine of something over something. I think what we want to do is sum the product here. Because we can pair these up such that we get... Ooh, do we? We can get a bunch of sines of 90s. Yeah, Crunchy. Okay, sounds like we're on the same track here. And SKK says EAIA is a matrix with zeros in every row except the middle row. Huh. I can't think too much more about that right now, SKB, because I want to focus on this trig problem. I can try to Google it a bit, but I don't know off the top of my head what the answer to your question is, though. The coefficients mess up the pairing. They're all 180 coefficients. Only the 90 sine of 90 on the end has a 90. I didn't write the pattern out that clearly, but everything from here to the dot 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 has a 180 in front. This, I think we just are going to evaluate it directly, probably, along with that. Two sine. I don't give myself enough room. So if we group the sine of 2 with the sine of 88, we can get 2 sine 45 cosine 88 and 2 is 86. I don't know about... is this actually going to help? We're cutting the length of the sum in half again, I guess. Sounds good, SKK. Apply everything by sine of 1 first. I feel like there's something... If we multiplied it by cosine of something over something, there's some kind of type of clever angle we could choose that will get us the exact, like a sum and difference identity. Oh no, I don't want to do anything with complex numbers here, Thunder. Hey, Peach Tea. Almost milk, I'd say that sum only goes to 89, and the last term is an oddball. I should really have written this pattern as plus 180 sine 88. Oops. Inserted right there. The 90 sine 90 says a different coefficient. So I'd only say the sum goes from here to here. Or I guess the last index would be 44 rather, the last value of x, because I think your sum would have to go from 1 to 45, but the pattern only holds for 1 to 44. But 90 sine 90, like we know what sine of 90 is, it's 1. Me too, Yanis. But this is a question from Karanji in the YouTube chat, so since someone was asking about it, I wanted to try and solve it. Yeah, we would get a sine of 45 in common if we continuously applied it, Karanji. I'm just trying to figure out, like, I don't know if this actually helps us. We want to get to cotangent. Cotangent is cosine over sine. We're just going to kind of get the same series back, but in terms of cosine. And I don't know what it's going to range from. Something weird. It might just range from 2 to 86 or something. That's what I did in the first step thunder. In the second black line. I don't think we... split sine 2 theta into 2 sine 1 cosine 1. The issue is that you get a bunch of powers of... You get a bunch of like cosine, like 2, 4s, and 6s in there that I don't know what you do with. So yeah, that was the first thing I tried. Yeah, Milk, if you want to see the sigma notation. I don't like using this identity because of that cosine theta really messes things up. You have to break down the angle of the cosine as well, and that formula is not nearly as clean. What I'm saying is that line there is 180. Oops. Terrible sigma. I equals 1 to 44, 2i sine 2i degrees. Plus 90 sine 90 plus 180 sine 180, but these last two terms we probably just evaluate directly. But only the first 44 terms have the 180 coefficient, but we don't need that sine of 90 for pairing either. X equals 0 slash theta equals 90, so that's half your terms gone. You know what? Before we progress further in the problem, I forgot with these tricky trig ones, we need to check if they're a real identity first. Like that's happened to me before. I'm not doubting you, Karanji, but I've had people with honest intentions give me a trig identity that isn't real. And I've spent way too long trying to prove it, so I do want to verify this in Wolfram Alpha before I forget. I was wondering, is Wolfram Alpha going to know that these are degrees? Let's find out. That's not good. No, degrees. Wolfram Alpha says this isn't a real thing. Why aren't you letting me... I don't know if this is degrees or radians. I don't know how to tell Wolfram Alpha degrees is the issue. Is that degrees? Okay. What? Degrees? This is sinh of 2? Shouldn't it be 4i? Maybe... Oh wait, you mean in this sum? I'm going for the initial part of the problem. It's just... every even number... Okay. And I'm a little bit worried that Wolfram Alpha is... Why is the imaginary unit... Oh my god. I do not want I to be the imaginary unit here. Oh, yeah, just break it into this form. Easy. Okay, it gets 51, 56. What is 90 cotangent of 1 degree? Okay. This identity, it is correct. Somehow. Just wanted to verify that piece of the puzzle first. Well, not first, in the middle of this. Oh, maybe okay, so if cotangent is cosine over sine, I think we do want to do this identity I started with on the last black line. Because that gets us the cosine on top, and then maybe we can figure out some clever sine of something over sine of something to multiply by. Maybe? Well, no. We should be able to do it from this step too, with cosine. It just needs to, well... What I don't like about this is we get the radical, the root 2 over 2, and it just feels wrong to have a radical be involved. It might be okay, but... Yeah, Karanji, this is a difficult question. Right, Thunder. I did do that. I guess I grouped 2 sine 2 with 178 sine 178. Well, I guess I did it over a couple lines. That's how I eventually arrived to this line here using that exact thing. Like I have the identity written up there. The thing is, sine of something times cosine of something. The trig identities don't work in favor of what I want to do, is the issue. Like, multiply my cosine of something over cosine of something. Sine n plus n? It's possible. We could split off sine of 1 from each of these. Then you do like a sum identity. I don't think you get something that's easy to evaluate though. I don't think you get anything that's particularly helpful with that. Okay, let's cosine over sine. Let's just I'm gonna try one more thing. If it doesn't work, then I'm gonna either give up on the problem or Google for the answer. But I think I want to turn all these into cosines because we do want to eventually get to cosine 1 over sine of 1. So what if we turn all of these into cosines using that formula there? And then we just blindly multiply by sine of 1 over sine of 1 and hope for the best, with identities saving us. My best idea. So this came from grouping 180 sine of 2 with 180 sine of 88. We're also going to group sine 180 sine of 4 with 180 sine of 86. Which means we get another sine of 45 times cosine. 86 minus 4 is 82. What are we going to get in the middle? It's going to be 44 and 46 in the middle? So it does go all the way down to cosine of 2 degrees. I'm going to say 180 sine of 180 is 0. I doubt we're going to need that for anything. So we do have a 2 sine 45 that we can factor out. And sine of 45 is root 2 over 2. Maybe we'll just leave it in that form, though. That's cosine of 6 degrees. This is now incrementing by 4 degrees each, I think. Four goes into 84, so if we have an initial 2 offset, we get to 86. Yeah. So now my idea was to multiply this piece by sine of 1 over sine of 1. I think there has to be a step something like this, something like it in this problem, because that's the only way you're going to end up with a cotangent that I can tell. And so what would have to be true here? This 90 sine of 90 is messing things up for us too. Sine of 90 is 1. Could say it's 90 times sine of 1 degree and include it in the fraction. Turn needs to get s in terms of itself, then you can solve for s. So I imagine you're saying to take one of my lines and make it equal s, but I don't know what you would do with that. The answer is Crazy Thunder. Okay, you think I'm close? I don't see what to do with this. I was hoping there'd be something more obvious. I think I want to look at the answer. Victory's around the corner? Oh, you don't know? Okay. It's like I'm just like I don't see it. I was hoping there'd be some kind of more obvious. I was hoping to use like a summer difference identity, I guess, or like maybe one of these, but it's not really. It's going the wrong direction. Like this sine times cosine identity turns things back into sines. Backward Geek, thanks for the follow. Subspace is U that is spanned by the vectors 1, -1, and 1, 2. My linear algebra is pretty weak. But don't those span R2 because they're linearly independent? Unless I'm missing something there. This isn't quite the same question. Also, if your question is really just like, why do those two vectors span R2, I can give you like an intuitive explanation for that. I just want to wrap up this question, and I think there's someone else who asked a question before that I need to look back at. So it's going to be a little bit if you don't mind. Okay, so I got to this step as well. What do they do here? What is this identity? What? Where does this identity come from? It's I saw you just messaged me, Thunder. Let me bring that up. Hey, Phobos. How's it going? Oh, this is stupid. You just need some random ass formula? I feel cheated. There's just some super vague trig formula that makes the problem way easier. So you would take alpha as 0, beta as 2, and I think you're in business. Yeah, so Karanji, apparently you need this formula. I don't see a way to do it without this formula. This is a stupidly hard question that I would not have gotten this on my own. So sorry, but let me at least try and explain what you would do with where we left off. Well, not here. You would want to take this line here, say that this is 0, and this is 90. And for everything else, use the formula that I was just saying on the screen, or I was just showing the screen with alpha equals 0 and beta equals 2. Because this is 0 plus 2, 0 plus 4, 0 plus 6. So it fits the pattern that the formula gives. Same here, Karanji. That's why I say this is a stupid problem. It's just... Arithmetic sum of angles? Yeah, I've never seen this before. So yeah, I'm sorry, but I think once you apply the formula like that, it should get you right to 90 cotangent of 1, but sorry, I should probably move on at this point because there's been a couple other questions people have asked. It's an interesting one. I just wish the solution was realistic for a student to get. Okay, and so if you like linear algebra, you're in luck. Because a while ago, SKK Baby asked a linear algebra question, and then we have to go to Backward Geeks question on span. So SKK Baby, a little while ago in YouTube chat, asked this, and I feel like there's something you can do linear algebra wise to figure out why if AB equals BA, then A is self-inverse. I wasn't able to figure it out offhand though. I should actually. What? Oh. Who cares? I'm just gonna try and Google like if AB equals BA, then A is self-inverse. It's also just not true. Oh. A is not invertible? Oh no, that's a different thing. So there's people talking about EII matrices, which I've never heard of. Because the zero matrix might not be an EII matrix, I guess. Oh, like the identity? So this is a square identity? Oh, but it's not necessarily a square matrix. Okay. Well, what is the inverse of a not? Oh, because it's EII, so it must be a square matrix. Is it just saying the identity is self-inverse? Oh wait, oh no, the I guess the identity matrix comes up in this? A and B belong to M and N. What is an M and N matrix? It's just a generic N by N matrix. That's probably it. Oh, do you know this, Yanis? That'd be great, because the more I read it, the more I get lost. Where A belongs to K. If A is a matrix that commutes with all other... Oh, A is a scalar multiple of the identity matrix, if that's true. Oh! So it's okay. So I guess I was confused SKK because I think that IN means identity matrix, not inverse matrix. Yeah, that seems reasonable because the identity commutes. I'm still have to Google it, but if linear algebra, if AB equals BA, then A is the identity. Simply said, okay. Let me copy that over to Twitch chat and like read through it. Said E1IA equals A E1I, like an identity that a horizontal vector? Would that be? It's just a one of a bunch of zeros. AB equals A small a times the identity times B. It doesn't seem true that A, well, okay, if A, okay, I don't know about that setup, but I think I can maybe understand the second part. Let me just hide problem because I. Let A equals small a times the identity. I'm just going to say I. Then we start with AB is equal to, we do this sub here for big A. And then here we use that, the identity matrix always commutes. That's a property of the identity. So IB is equal to BI. So we commute these two. The small a is a scalar, it stays where it is. And then I didn't actually know this, but I guess scalar multiplication commutes with matrices. So small a times b is equal to b times small a times I. And then, oh look, we happen to get big A right back out. I think that's the chain of logic that happens at least in the last thing that you said. Because scalar multiplication and the identity commute individually, you can prove that AB equals BA. The setup to that, I don't know exactly what's happening with that. Oh, yeah, let's explain that with EII. And it's what he XD says. EII, these are the dimensions of the matrix, I think. So it's I by I matrix, which means it's a square. You have ones on this diagonal here and zeros everywhere else. So it's like the identity matrix, but it doesn't necessarily have to be a square. In this situation, it is a square because it's E sub ii, but you could have like E sub ij or actual numbers in there too. But it's basically the identity matrix. For the purposes of this problem, you could think about it just like 1 0 0 0 1 0 0 0 1 is E sub 3 3, I think. I haven't actually used this before, but I think that's how I'm interpreting it in this problem. Does that help, SKK? Yeah, right. So that matches what he was saying. I mean, I think maybe the middle line part is potentially confusing, but I think they mean that diagonal that I put the ones on. You know this way they meant that? Oh, really? He? You got it. You don't understand why I complicated the answer with the EII matrix. I think because that's how you would think about it when you're studying linear algebra at a higher level, or even just algebra in general at a higher level, and that's why professors often give an explanation that's like that. But it's definitely, this is confusing to me too. I'm not completely sure that what I've told you is right, but that's my best like interpretation of it, I think. Because my linear algebra is pretty weak for the most part, so. But I think that's what's happening in what you said there. SKK, I mean, I guess technically you're right, EXE, you would have to prove both directions. Well, no. Oh, wait. We did the reverse direction if we're looking at SKK's wording carefully. But going off the work that SKK put aside from that, I think that's the explanation. For the work that SKK's professor gave. But it might be that the thing that we actually proved is if you switch to the if and the then. But yeah, I don't know. SKK, I think we've kind of answered your question without trying to make it more complicated. If you need anything else, let me know. But if you got what you needed to get, then I'm going to move on. Okay. As long as I did the direction that matters, then it's the important part. Scottish JC, this is harder than Malski. People always come with some hard questions. I agree. So sounds good, SKK. Thank you for the question. Hey, Bob. I mean, this next one is gonna be a little bit easier. Backward Geek, are you still around? Sorry about the wait there. Oh shoot, when I try to add them in chat, they may have had to leave. I'll answer it anyway though. Maybe they'll check the VOD. So I guess we took a little bit too long to answer, but Backward Geek wanted to know basically why do the vectors 1, -1, and 1, 2 span R2? I think that's what we distilled their question down to. And so I'll just kind of explain that and hope that Backward Geek checks the VOD or something. What are our vectors? 1, -1, 1, 2. Okay, so let's draw just the vectors that were given here. We have 1, 2, and 1, -1. So immediately we can see these two vectors. They're not a direct multiple of the other. If they were, they would be on the exact same line. Like one would, if they'd be in the same direction, one would just be like bigger or smaller, or maybe flipped, but still in the same direction. And so immediately, so just working in 2 dimensions, it's a bit easier to tell when you span R2 because that's the only thing you have to check for. What actually means to span R2 is that you take linear combinations of these two vectors and you see how far those linear combinations can take you. And what a linear combination is, I guess algebraically, is a constant times your first vector plus a different constant times your other vector. But more intuitively, it means that we can make these vectors as short or as long as we want. We can also flip them in the exact opposite direction, and we can add them together. So remember that like 1, 2 plus 1 -1 means we start at the end of 1, 2, and then we go another 1 -1 to end up there is the sum of them. And the thing that people studying linear algebra care about is whether through, an infinite number of sums of these vectors, if we can go everywhere in R2. And because these aren't basically the same exact vector, we can. You can take just copies of these vectors and get anywhere you want to go. If you were to imagine these as roads and follow them along, you're allowed to stop short on the road if you want. You can go past that road in the same direction. But you can, for any point you name, I could figure out a way to get there using only these vectors. So, if you have a point way over here, I can eventually build a bridge with these vectors to get over there. But how did I draw the arrow like that? That's the idea of span. I didn't quite hit it, but for any point you can name on the R2 plane, you can use these vectors to eventually hit it. The only situation in R2 when you can't, or when you don't have that, is if you have, say, one vector, call it 1, 1, but your second vector, let's say it's 2, 2. No matter how we build this bridge, we can only ever stay on this line here in either direction. So we can only ever hit a point that's on this line. If you want to prove this doesn't span R2, you could, say there is no linear combination such that these two vectors can make up the point, I don't know, or the vector, sorry, 10, 2 or something. Just anything where y doesn't equal x. Equals like this line is y equals x. Well, actually, it's not a coincidence, but so yeah, that's kind of the idea of span. It's where in R2 can you actually get. That's the intuitive idea, at least, of what span is. And the same argument can be extended to like higher dimensions as well. It gets a little bit more complicated there. You have to a bit more you have to check for, because you can have vectors that seem like they're on different lines, but if you actually, you can add up maybe two of the vectors to make a third vector, and that breaks things. So yeah, horrific. I don't think there's anything else in queue to answer after this, so we can go to yours. And Gaurav, I see your question there. It looks like a multivariable calculus question. Portions of the cylinder surface situated inside the sphere. I can probably work my way through that, but I need to do Hurwick's question first, and then you'll be next. In KVD, oh, that looks terrible. I don't know that I can even answer that question. I'll copy it to Twitch chat in case someone wants to think about it. But you're going to be third in line now. I have a question from Horrific, a question from Gaurav, and then it will be on to you. But even then, off the top of my head, I don't know how you even start with a question like that. What about this question? If I have a 6-foot sandwich brother and an 8-foot sandwich, if you steal his and eat both, when it's next time you'll get hungry. I feel like that'd be... I don't know what kind of function that would look like. I feel like your hunger would increase like logarithmically. Or like you get super hungry at first, and then you stop getting hungrier and hungrier. I don't know. There's probably a differential equation in there. So we have the growth of algae in a pond here. Mass of algae on the y-axis, time in days on the x-axis. Population of algae in the pond at the beginning. So I would think we just look at time equals 0 and guesstimate it to be 5. What did you say? Oh, you did a lot more work on this than I did. Hey Neg, Borsa, welcome in. You're saying approximately 0? I mean, maybe this feels like maybe a class-dependent thing. So I would think that the scaling isn't so small that you can't eyeball it to say 5 or so. But it might be in the context that you're working in. It's okay to say approximately 0. So this one, I mean, my instinct is to say 5 for part A, but it might be that this is fine for your context. I'm going to take the algae to reach 70 kg. Well, when we say it's 14.5 days here, or so. Linear interpolation. $14? I mean, that's pretty close too, I guess, but are you supposed to use this, like, 60 at 13, 80 at 15? Yeah, no, I get the idea where it's 70 minus 60 over 80 minus 60. I assume the 15 minus 13 is off to the side. I don't get why we can't just eyeball it. I haven't done... if we're doing linear interpolation starting from 13,60, time is equal to 13 plus the slope. Is that, no, it's not the slope. The slope is 15 minus 13 over 80 minus 60. And we're multiplying it by 10 to get to 70. -40 not 15, 13? Wait, what's supposed to be 40 minus 20? We're gonna be, that is a lot of sandwich. It's true. Oh, you just edited it? Okay. Wait, why is it 40 minus 20? I don't see where 40, like, minus 20 comes from. I try to figure out how linear interpolation works because I haven't done it in a really long time. We're using the point 13,60 and 15,80 to make our slope, which is 80 minus 60 over 15 minus 2. Which is 10. And then we take that slope and extend it out from 13,60 to... It doesn't look like 60 at 13. 15 days. I guess are you just supposed to like do a rough estimation here? Because this is really like the numbers that you're pulling out here are a little bit weird to me. But I don't know if that's okay to do in this class or not. Because like, I feel like it's closest to 55 here more than anything else at 13. But it's definitely like erring towards the side of 50, I think. At day 15, calling it 80, it's like, that's maybe like a little bit low, but I can at least go with it. For 13, it definitely seems closer to 50 if we have to go by tens. And I can't really figure out where this piece is coming from. I assume you've rearranged some formula that you were given. I can work out like a different way to do linear interpolation in my head. I don't know what this way is though. What was I saying for C? Maybe that'll like, or what do you say for C? But it's a massive algae after 10 days. It just looks right about at 30. But you have to do this interpolation thing again? I don't get why you can't just look at the graph. I'm not saying you're doing something wrong. I don't know why you're expected to do this weird linear interpolation thing. Like, I feel like just looking at the graph is perfectly adequate for this. Do you have a formula you were given to do this with? Yeah, Gaurav, I agree. It seems needlessly complicated. But if that's the way you're supposed to do it, Herpik, it's the way you're supposed to do it. So I have a hard time figuring out where this formula comes from. I probably shouldn't spend forever on each of these questions like I have been today, but my idea is that you have this exponential looking population curve. And we're gonna take 13 and 15 and I'm just gonna edit it to be 50 rather than 60 and 80. We're basically forming the line between these 2 points and plugging in 70 for the horizontal value. So I was trying to work it out intuitively. The equation of this line, we would say, if I do like point slope form, where x0 and y0 are just any example point you want, I'll take 13, 50 for x0, y0. Y minus 50 equals, slope is rise over run, 80 minus 50 over 15 minus 13, x minus 13, and then we'd simplify this and then eventually plug in 70 for y. 30 over 2 is 15. What is 15 times 13? 225 minus 30? Right? Is that 195? What a weird number. 13 squared is 169. 169 plus 26. Oh, hey, it's 195. Okay, I guess this is okay. Negative 195 plus 50 is negative 145. Now we take y equals to 70. We get 15x minus 145, and we solve this for x, and x is our time. So 70 plus 145 is 215 equals 15x. That doesn't go in evenly. That's annoying. But, oh, I mean, it's not supposed to. I plug this into a calculator. You can simplify the fraction, but why bother? You're going to plug it into a calculator anyway. Zero, 14, and 35. I mean, I was trying to check your method too, I guess. But if I go off the eyeball method, I think you're about right. So I also get 14 if you round it down. Zero is a little bit sketchy for the first one, but I can go with approximately 0. 14 for part B, I agree with if you round it. 35 is also a little bit sketchy, but if that's what your interpolation gets, then it's not that far off, so. I'd rather just look at the graph and say it's 30, but 35 isn't that far off. I would just look at the graph and say the answer to part A is 5, about. The answer to part B, 14.5 is what it looks like to me. And the answer to part C is 30. But the thing with approximations is I don't know if your approximations are good enough for what your class is doing or not. So I've heard him saying that you're wrong, but that's not how I think about the problem, like not being in the class that you are, I guess. See, I hope it helps. I should probably start thinking about Quadrilateral's question. Sorry about the wait there. Oh, you need the area of this. I thought it was the volume. Ooh, that makes it a lot harder. Okay. Shoot. The area of the cylinder. How do we get area with the triple integral? No worries, horrific. Um, Interesting. I'm gonna need to graph this. Because x squared plus y squared equals ax is not centered at the origin. Does those 3D... Will it do a slider for me? Oh yeah. Oh yeah. Okay, yeah, so it's tangent to the origin basically. Which adds another layer of difficulty here. Oh no. Oh, okay, thank you, Jed. Okay, good. At least they're in line now. Huh. I mean, let's go deeper. Oh no, the sphere disappears completely. Yes, it is a neat shape. So we want the surface area of the cylinder that is inside of this sphere. Desmos doesn't... It's a little bit hard to get things to work right. Or to display the exact thing we want, but... Oh, well, glass chains. I don't know I can answer, but maybe someone around will be able to answer it. It's the problem that's up there, Bob. I thought this was going to be... When I first read it, I mistakenly thought it was going to be volume, and that we can work through the calculus here, but now I realize it's surface area. The answer is 4a squared? That's so, like, simple. That's interesting. Just out of curiosity, is this the same thing? No, it's not. That makes sense, but... Yeah, I mean, we definitely want to do it in cylindrical or spherical coordinates, probably cylindrical. But I'm wondering if there's like a two-dimensional solution here where a cylinder is just a stack of circles and we're slowly taking off a little bit of the circumference each time. I wasn't trying to get the intersection. I was just seeing if... It's about how the formula here relies on it being a function z equals f of x comma y, but we don't have z in the equation for the cylinder. Given him to use polar coordinates, but cannot understand how I could have progressed. Yeah, I mean, we definitely don't want to do this in Cartesian. Oh, really, Joseph? So yeah, Zach, I'm struggling with this though. Well, we want the surface area of the cylinder that's inside the sphere. And for surface area, I don't even know. Yeah, class chains. I don't know what I'm doing with that, even less than you, I think. Hyperbola? Or parabola, more like. Slide a bit. Oh, it just makes things bigger or smaller. It stays consistent with like where it's tangent. So yeah, like we don't have to be worried about different values of a. Um, oh, thanks Wheeler for taking a look at that. My linear algebra knowledge is next to zero. The main property the surface has, the fact that our sphere equals the cylindrical coordinates relative to the center of the sphere. Yeah, like the R in cylindrical is the same as the rho in spherical, if that's what you're saying. Right, it's like that's the letters that are normally used, I think. Um, so yeah, questions with that problem there that I have no idea what to do with Wheeler. The problem that I'm looking more at right now is displayed up above me. The surface area of the cylinder of this red cylinder that lies inside the sphere. And I can imagine how we could... I think I can imagine more or less what the bounds are going to be. But I don't know what our integrand is, I guess. Polynomials probably isn't going to do it in cylindrical. Surface area in integral in cylindrical coordinates, because I definitely don't want to try to derive it. Yeah, soon. Did you go the full like 13 hours? I forgot to ask. Oh, power outage? No. Pretty much exactly 13 hours. Okay, at least you got your goal, I guess. Just start trying to do things. I don't know exactly. So I want to set up some sort of triple integral, I guess. And I want to multiply by 2 and make the z's go from 0 to a. So this is as far as I've gotten in my head, I guess. And we'd have d something, d another thing. I'm trying to play fill in the blank right now. We definitely need something inside, and we need to figure out what r and theta need to be. So a cylinder in cylindrical coordinates, like what is that? Isn't that just a circle in polar coordinates? But we're a little bit off-centered. We're centered at 0, or a comma 2 over 0. More luck than anything else. Yeah, that's something right there. To a cosine theta. First circle center at a0. So we want just a cosine theta. Is that right? Looks right to me. Okay. So our cylinder now a sphere in polar coordinates, or in cylindrical coordinates. We have an x squared plus y squared. Z squared stays the same. So is it really just r squared plus z squared equals a squared? I guess it would be. So I think this is going to have something to do with the integrand. I don't know what yet. The sphere is going to affect our bounds. Maybe r goes from 0 to root a squared minus z squared. And theta, I think theta is going to go 0 to pi. Because that makes a full loop for the cylinder. But the integrand. Ben, what's that? What's what? To pure math. Nice! Studying math in September? That's awesome. I hope you enjoy it more. One of as someone who did applied math, you know, I am a little bit sad, but as long as you're doing what you want to do. Why? This is the type of formula that I want. And there's the 30 streak. Holy crap, thank you. Hello to you too. But the issue is that we have a function of 2 variables, and this equation is in 3 variables, and I don't know how we make that translation. Hey, Territar. I don't know, I think I've technically done a Jacobian before. I don't know. I don't remember what they are, though. Oh, and the current question is up above there. What does this help us with? Oh, this is probably what you're talking about, Territar? Change of variable formula. It's going, Waffle. We're working on this really weird multivariable calculus problem. We gotta get the surface area of this red cylinder that lies inside the green sphere. And I'm trying to set up the triple integral to do that with. I think it's weird because I don't know how to do it offhand. I think I can do it. I'm just struggling with doing it. Hey Storm, that's what you're talking about. I literally like just said it, but we're trying to calculate. Is this a 1 variable calculus class you're doing this for? Have you not done a triple integral? Oh. How would we do this with a single variable? So we're trying to calculate the surface area of the cylinder that lies inside the sphere. Or it's displayed up above me there. Use triangles? Yeah, I mean, I think, oh yeah, please help if you know how to do this. Although I just learned that the person who asked this in the YouTube chat, Gaurav, has not in a multivariable calculus class. just a single variable calculus class. So I'm really confused on how they're expected to do this. Wheeler, I'm pretty sure that just it makes the cylinder go through the YZ plane, so it'll be like parallel to the like it. Oh, that's not like that's what I envisioned, but that makes sense. It just is a rotation, basically. It's probably the same surface area. How would you do this, especially with one variable? I can imagine how you can maybe you could maybe imagine this cylinder as a bunch of circles stacked on top of each other, where you're progressively cutting off the top of the circumference. But how? Yeah, I was trying to use cylindrical. The only thing I didn't know how to do is the integrand. But apparently the person who asked this question is not in a multivariable calculus class anyway, so I almost don't even want to pursue what I wrote on the board. You got 2 pi a squared, Teratar? Gaurav said the answer is supposed to be 4a squared. Somehow. Yeah, this might be. I think this is going to be a Googler. This is basically a special case of the same problem. Or not a special case, just a case of the same problem. The cylinder is x squared plus y squared equals xa. I haven't read your entire comment yet, though. It's like that, but... Okay, this person doing it in cylindrical. Z equals Z. Oh, parameters are all in theta? Is that what they're doing? Yeah, Storm, I think they specifically do it like that so that the sphere and the cylinder have some kind of like constant, like it's always tangent at the same point as you scale A. I assume that's why they constructed it like that. Because if the cylinder is centered at the origin, I think you just use the normal surface area formula. You don't have any calculus to do. Yeah. It's happening. Okay, so like this is probably something that we could copy and apply to this problem, but it's not single variable calculus. This is the person who's asking it, like they haven't done a triple integral before. Uh, 4a squared according to Gaurav, who asked the initial question. For this one, 256. 2 to the 6 times 2 to the 2 is 2 to the 8, so 256, yeah. Is the answer to this one in theory. Gaurav, if you're there, do you at least know like polar coordinates? Because I definitely don't see how you do this with a single integral, but we can maybe just give it to a double integral with this technique rather than a triple like I was doing. Actually, no, you said you're given a hint to use polar. So you presumably do know polar. Um, I'm just trying to look at this and see if I can like maybe distill it down to something that's a little easier. Captain Scaros, thank you for the follow. Yeah, I'm sorry. I bet that I could follow this and just like copy the work here, Gar, but I don't know how to explain it. Or I don't know how to do the problem in a context that would make sense for the class that you're in. I don't know that it's possible. So if it help you, I can try and do this multivariable calculus stuff that you haven't learned, but otherwise, I don't think I can help you. Hmm. It's an interesting way to parameterize the surface, I guess. Yeah, that's what I was gonna do. Like that's how I was starting to set it up, Storm. But I feel like this is already not what Garev is supposed to do, so I don't feel like there's a point in pursuing it further. Yeah, SPQ, I was trying to. I think I understand. Like, I was imagining how this cylinder is really a bunch of circles stacked on top of each other, and we're really just chopping off a part of the circle, or I guess adding on a part of the circle each time. I was trying to figure out something like that to basically put it into a single variable, but I don't know how you actually do that. Yeah, Wheeler, that's what the person said, is the answer. Yeah, I got the SPQ. Like, we have a complete circle up here at z equals a, down to basically 0, where x equals a. So I can go from a complete circle down to nothing. Yeah, Wheeler, 4a squared. Integral of 1 from x equals 0 to a from z equals 0. Oh. See what Obi put. Oh, wow. Yeah, it's another like it. We're doing just like the generalized version of this problem. It's that we would have a equals 2. It's good to see. Cylindrical coordinates. Use the surface area function. Like you're keeping Cartesian there, Wheeler? Like this? I guess the integrating X is not going to be easy there. It doesn't seem. Or is that a sub? Maybe there's a sub. Well, shouldn't it be X squared? Or is it? That's probably possible too. Makes Bob. Yeah. It seems like there's a couple ways we can do this. It's just none of them fit what Gaurav over in the YouTube chat is apparently learning, which is single variable calculus. I don't know. I kind of just want to call it on this one because I think I could more or less like copy like Obi's work here and thank you for finding it, Obi. And just like instead of 4 and 2, we have a and a squared. But I don't think that's what this person is supposed to do. Well, yeah, Storm, but if you're just taking single variable calculus for the first time, you don't know what a triple integral is or how to do them. And if you do that on your homework, your teacher's going to know that you're getting some outside help you might not be supposed to be getting. Or, you know, like you don't understand the actual material that whatever the teacher's intention was, I don't think is being followed if we do a triple integral, even if it's one variable after another, like an iterated integral. So yeah, I don't know. I don't know what that one. I will derive. Is that like I will survive? Oh, that's what a talus is. Yeah, ate. Can always use a cat. No. Hey, Ayush, you're at Calc 1? Oh, well, Welcome in. Well, I don't know if you have a question. Top one I can actually do. Binging cat videos. Oh, that sounds nice. I'm gonna erase what I have on the board. Hate the failure. That was from the problem before this syntax. Oh, it's because we just needed a decimal approximation. I didn't feel like reducing the fraction if I was just going to plug it into Wolfram anyway. What's the problem? Me IRL. Oh, great, Waffle. Well, glad to hear it. For a squared over 3? The person said it was just 4a squared. I haven't, like, verified it, but... For a... the failure, yeah, just put the question there in chat. Calc 3 isn't my best, but... can usually figure them out with some Googling. Choose matrices to solve system equations instead of just elimination. If it's more than 2 equations and 2 unknowns, I think I prefer matrices for elimination. Because it's annoying to write the x's and the y's into the z's over and over again. But it's all the same thing. Any integration beads other than the MIT one pretty soon exhausted their previous ones. That's an impressive statement. The MIT integration bead run dry for you. You're doing it just 2? Oh, that's kind of annoying then. Doesn't really save much writing. I think I've seen Black Pen, Red Pen talk about like Berkeley having a math competition. I guarantee you Google's gonna say, oh, looking for Berkeley near your zip code. Oh no, it didn't. I don't know if they do integrals, but let's see. Yes, Fembox, and you use the world's most vague trig formula. I got, like, the first step that I took was helpful, and then, there's this stupidly vague trig formula for the sum of signs that you have to use. Actually, Thunder DM'd it to me. I can show it. Because I still have it handy. This is the formula that you use. You would take alpha, I think alpha equals 0, beta equals 2. I think. Maybe alpha equals 2, beta equals 2. Now I look at it again. Oh, really? Pen blocks? That's interesting. Yeah, I'd never seen this one in my life, and we basically had this expression up here, and I tried to do something completely different with it, and it did not work out. Proofs? Doesn't seem like the Berkeley one does integrals. It's on the yeah. So that's the only other competition I can think of off the top of my head. For integrals specifically, I don't really know anything syntax. Let me look at what Wheeler. Single variable temp is this. Suppose t, the height of the cylinder, goes from 0 to a. Then for a fixed t, let f of t be the length of the circle arc, passing the plane z equals t. Hey, Siphon GT3, welcome in. I'm in California. So that's a thought, Wheeler, trying to get the portion of the circle inside the sphere in terms of t. Actually naming that f of t seems a little bit difficult, though. Proved it a week ago, too. It was hard work. Oh, nice. Dang, I wish that you weren't busy with that student. But I guess we still found the formula anyway. Was there? Oh yes, KVD asked a question in YouTube chat way earlier. I don't think I can do it though, and I doubt KVD is still here. Answer a math question for me about probabilities. Sure, Siphon. I still try. I want to switch up the music. As soon as I always see that question, I'm gonna just look at some more physics in the meantime. Oh shoot, we do have that drawing thing from Joseph from 2 hours ago now because things got so busy. Which is kind of weird to me that, like, I feel like the math really hasn't slowed down over the summer like I thought it would. So we're already like nearly through July, and I feel like it's not as busy as it was in like May, but it's still like pretty busy. Oh yeah, Nikos. It's there. I mean, I don't know. I haven't gotten a haircut that I actually like. I've always been like neutral at best towards my haircuts for a really long time. Like I haven't had a haircut that I actually like. I feel like. Well, thank you, Nikos. I was just getting like way too hot, and it'd been a few months, so it was like well past time for me to get it cut again. Uh, a poker problem? Yeah, I can try with it. I'm not too good at like game theory, but maybe someone around in chat who knows, or we just like type it out there if you want. There we go. Bob is in. In the meantime, I'll see that question. I did get a channel points redeemed to do a drawing of a cat taking home the wrong kitten. Do blue. No clue how I'm going to draw this, but I'll take a break from this drawing as soon as I see your question, Siphon. It's gonna be a pretty long cat, apparently. Okay. Not the worst body of a cat that I've drawn in my life, right? Let me check on chat. An argument with a friend? Okay. We'll have a, it's gonna look like the mom cat is like, this is like the mom's cat kill, I guess, but oh well. I'm trying to go for like a scruffy looking kitten. This looks like the cat, like, this doesn't look like the cat is carrying a kitten gingerly. This looks like the cat is a little bit dead, but you know, oh well. And like, surprise, exclamation mark, question mark. Cannibal cat? Yeah. Oh. Let's see what the question is. There's no fun unless something is at stake. True. It's a big rat pretending to be a cat. In the game, always. Oh, okay, cool. Thank you for translating it. And you'll play cards twice. In a game, there's always a potential of winning and losing against another player. Oh, no worries, Siphon. So this is basically asking if the two events are independent of each other or not, as far as I read it. And so I think if you were to shuffle the cards between each time and you start with a fresh deck each time, then it's the same probability. If you don't like start with a fresh deck each time, then it'd be hard to judge, but there's going to be some kind of small change depending on what cards aren't being used for the next hand. You can learn any language a single day, something would be like to learn Don. Oh. Speaking of course says Rust. Any language in a single day. I mean, I feel like I should choose some super hard language. I'm not talking about like programming language, but like Spanish would be cool. Like, I'm in California, there's a lot of Spanish speakers here. Oh, and Koopa. Now you're confused. What is 8 divided by 2 times 2 plus 2? It's bad notation, that's what it is. Welcome in, Koopa. Yeah, you should read it from left to right. So you do 8 divided by 2 first, which is 4, and then you do, in parentheses, 2 plus 2 is 4, so you end up with 4 times 4 is 16, I think. Tomb? I never heard of Tomb. Not because the cards are not shuffled. No. So I should choose a hard language, but I'm not like I didn't actually choose a hard like language. I mean, I'm not saying Spanish is easy, but that'd be like the most like practical for me to learn. But I should choose something like, you know, like Mandarin or something that would be super hard to learn. The internet has you fed up. Oh no. Oh yeah, with that problem, I remember that thing being. I remember a lot of people asking about that when that like went big. Icelandic is hard, yeah. I've heard that. They're not been. Yeah, so I don't know that there's necessarily going to be one person with an advantage or not Siphon. Like, just based off knowing winning or losing. The odds are going to change, I think, but not in a way that you can really predict unless you're counting cards. Territar, according to the person who asked it, the answer is 4a squared. I didn't verify it. And hey, Finray, welcome in. Advice for a first-year engineering student? I mean, as Sunlock said, I guess, like, study. I don't know engineering math, but if you're in your first year, you're probably going to be doing math, like, just, like, general math classes that me or someone around here can probably help with. If I can give you, like, general life advice, then just, like, try new things and keep an open mind and be okay with, like, you know, switching your major. Like, I started out as an engineering major, but I switched after my first year. So he says, get to know your professors, yeah. Especially if you're ever gonna need like a letter of recommendation, it's gonna be even better to know your professors. But I feel like probably asking like academically, what should you do or what you pursue, which I have a little bit of a hard time like giving advice about, but it's a good like degree to get. Yeah, life advice, just like say yes to things if someone invites you somewhere, as long as it's not completely irresponsible, like be safe. But I didn't do a very good job of saying yes when I was first going to college. And being more spontaneous, so I'm probably not giving you the advice that you are hoping for, but just in general, like keep an open mind to things. Yeah, well, I have like a little bit of a similar question. Like, if you only know that one person, I mean, it's about poker. If all you know is that like one person just won or lost the last hand, I don't think that's enough information to know how the odds have changed. You can theoretically know how the odds have changed if you're counting cards. But if you remove cards from the deck, you're definitely changing the odds from the next hand. Just how they're changing depends on the order of the cards and which ones were discarded. Yes, Stefan, there's more that you want to talk about there, please, or anything you want to clarify, please do. If not, maybe I'll go back to doing this drawing redeem. And then probably do a little bit more physics studying before wrapping things up for the day. Unless someone else asks a question. I guess we should make these kittens like clearly different colors. So we have another like scruffy little kitten over here. I feel like I'm haphazardly drawing this, but it's actually like one of my better drawings of a cat. Which isn't saying much. That's a very like low bar. And because this kitten is getting left behind, I guess it's gonna be crying. There we go. I guess, yeah. Erasmus? That sounds like a planet or like a moon, rather. I played Gartic Phone once. I think it was not a good night for me. We made it open to anyone who wanted to join, and let's just say some trolls joined and were drawing things that were not good. And even if that hadn't happened, I feel stressed out by having to be like Gartic Phone makes you be creative a lot. And I feel like the things that I was putting in for prompts are getting more and more stupid. And my drawings weren't very good. So I feel like I was like not at being a good Gartic player. Oh, Felix, I only just now saw what you posted in the Discord. Oh, Finray, thank you for the follow. Oh, you know, if you're interested in math streams in general, let me shout out a bunch of people, and for anyone else who's interested in math streamers. So lots of people I can recommend highly. For engineering math, I don't have a particular recommendation. The first on the list, Actual Education, might know a bit of that. Because he also knows physics. Talos might know some too, actually. I'd say maybe the first person on the list, Actual Education, and maybe even the last two on the list, Physics and Depression and Talos teaches. Might be a bit better with engineering specifically, but all of them do like math help in some form. So I recently found it very hard. I don't know if anyone might see a shortcut. This just does like the entire work for the problem for you, doesn't it? I guess you have to deal with the coefficients. So you can't just do it directly from the first step of the problem, but it seems like what you want. Okay, see you, Nikas. Sleep well. What a weird formula. I kind of hate it. Oh wait, did we only had even numbers for theta, but you could do a change of variables and take care of that, I guess. So that's still okay. Yeah, okay. I can buy this. You have to take theta equals like, 2t or whatever, I think, to make it work, but there's nothing wrong with that. God, I can't believe they actually... I wonder if you can prove without complex numbers. But I don't know. Oh yeah, theta's just 2. I'm stupid. I forgot we didn't have a variable in there. We just had to evaluate it straight up. How much more of this chapter do I have? Okay. I mean, skipping over the applications part, I have 1, 2, 3, 4, 5, 6 more pages. That's not too bad. My issue has been I keep falling asleep after like 2 paragraphs. 2 pages ahead of you in the chapter? Okay. I honestly, I would really need to go back and reread this through from the beginning because I'm really starting to lose the thread in 3.6, but I want to push through and just at least read all the text, even if I don't understand it, and then hopefully in time for Saturday I can go back through and give it a second look and hopefully make it sink in a bit more. In any system, C12 is equal to C21. Really? C13 is equal to C31. Oh, hey, Cruz. Huh. Oh, is this like transposition? Oh. Yeah, if you think about it as a matrix, that's the... A would equal A transpose, is what they're saying. I'm doing good. How about you? Based on conservation energy? Another exam, feeling good. Oh, nice. Congratulations. Are you doing summer classes? Or like, the ones that I've heard having exams at the end of July. And that's... I guess if you're taking a summer class, that's not unusual in America, but... It's not something you hear about, like, too often. Oh yeah, Dr. Hick was just here earlier and we were talking about it. Oh yeah, Territar. I've heard that's at least partially based on your computer's hardware. When Wolfram Alpha tells you standard computation time exceeded. So I've had something into Wolfram that works for me, and then someone in chat does it, and it doesn't work. The exam weeks ago, you just got graded one of them. Oh, okay, nice. Well, congrats, Cruz. Turn some Daisy. Awesome, Koopa. Hope the Daisy goes well. Appreciate you saying hi. It's true. I've seen it happen. It uses your hardware to calculate this stuff, I think, which I think is kind of normal. Like if you go to like chess.com and use the engine, I think it uses your hardware. It doesn't put it on the servers. i9? Now, I don't know about that then, but maybe Wolfram still like, maybe it's not completely based on your hardware. I don't have chess.com. I know for Lichess it uses your hardware because I can hear my computer like my fan getting louder when I go to the analysis board. Same question of 3.2 can be solved for fees in terms of the queues. Okay, yeah. I wouldn't want to do this with everything as a symbol, but I can see how you could do it. Oh, this is going to be... Oh, I think this is going to explain something I was confused on before. Where did they say it? They said very explicitly that something would overdetermine the system. Right here. And I assume that's the issue with what we just saw with the system of equations. So the word overdetermined stuck out to me as having to do with the system of equations, but I didn't really understand what this meant. And maybe now in 3.6. That's what this means. To govern any linear physical system. Study mechanical structures too. Analysis of electrical circuits. Interesting. Where the superposition principle can be applied. Capacitance coefficients for two plates. Let's say a flat metal box. I assume this is a conductor. That's where we're going to choose 0. Okay, yeah. Various distances separating the plates from each other. RS and T. Hey, astral procrastination, you don't miss electronics. I thought it was stupid when I learned it in my physics class, but just like on my own, I've been studying E&M out of this book now that I know multivariable calculus, because the physics class I took didn't use multivariable calculus at all. And it's been completely different for me. I think the math has been so much fun. It's really challenging, but doing this kind of changed my mind on it. But either way, welcome in. Of a general relativity / Cosmo guy. Oh, nice. I'd love to know more about physics in general. I majored in applied math, and I really like differential equations and that sort of thing, but I care more about any type of math when I can see it actually being applied. So this has been a really cool way to apply the math that I've been learning. Is the PDF free to download? I'll just say the PDF is posted in my Discord without answering that question specifically. I have been doing this reading group on Saturdays. And so you don't have to be a part of the reading group if you don't want, but if you just want the PDF, oh god. You can check the pinned messages here, and it's down there at the bottom. Oh yeah, thank you, $10. But yeah, on Saturdays I actually will get in voice with anyone who wants to participate, and we work through some of the problems from this book. But right now, since there's just kind of a slow time with no one having a question, I'm just doing some studying. But yeah, it's been happening for a couple months now. It's been a lot of fun. I know where the links went. Oh, for the JE. Those JE problems are tough. I remember seeing you do a couple of them, Phobos, and they really test you hard. Top and bottom of the box. R, S, and T. This is a weird way to show R, S, and T. I would rather just have the line in the middle, but they do everything but the middle instead, I guess. Compared to the length and the widths of the plate. The J ADV, it's for kids? Does the ADV stand for advanced? That doesn't sound like it's for kids. Kids with math PhDs. Top place. I mean, I believe that. I don't think that. I feel like it's probably still not easy though. Neglect the edge fields in estimating the charges on the plates. Of the capacitance coefficients. So potential box shouldn't be zero. We can write in general this stuff. Where phi2 is made equal to 0 to plate 2 by connecting it to the box. B1 over R? I guess so. Really? E sub S is phi1 over. That makes me uncomfortable when R and S are constants. But I guess if their R and S are pretty small, surrounding plate 1 does Q1 a... Okay, sure. Oh god. This is gonna be rough for me. I'm just gonna keep on reading through the text here, but this is... I don't see where a lot of this is coming from. I still want to at least like have read the text and then go back to the beginning and read through things again. So I feel like it's just... I'm able to make connections for the beginning and the end. I hope at least. I don't know if I'm gonna be able to read through this entire. I mean, I'm probably not gonna read through the entire thing on stream right now, but so let's make some more progress. See if someone asks a question in the meantime. Letting R approach T, but S remains S. Hey, Kobe Cristiano. Yeah, go ahead. Hit your question in chat there. Or I have a Discord too if you want to post a screenshot. Astro, thank you for the follow. Consider a capacitor of capacitance C, the potential difference phi between the plates. Charge Q is equal to C times phi. Isaac Newton. Yes. If it's a question that I can answer, I will do my best to answer it. My background is I have a bachelor's in applied math. The things I'm best at helping with are like calculus and below. Find the range of mod x plus 1 over mod x? What? Yeah, if Isaac Newton's asked me a question, I'm a little bit nervous. But, so, but Kobe, for your question, the range of mod x plus 1 over mod x. Don't you need something mod x? Like, I feel like there needs to be another number in front of there. It's gonna be easy for me? Okay. Just see if I'm not crazy. What is... If I just Google mod x plus 1 over mod x, does anything come up? Oh, could it be like... Does this mean like maybe the modulus of x, which would be the absolute value? Like, could you maybe have x plus 1 over the absolute value of x like that? Is that what mod means here? Because I'm thinking of like, I initially thought it was modular. Oh, okay, that makes more sense. Okay, in Isaac Newton, determine the set of integers n for which n squared plus 19n plus 92 is a square. I need to think about that. I'm not sure offhand how you do that. I probably can figure it out though. Maybe, since Kobe asked their question first, let me work on this. So we want to figure out the range of this function here. So let's I'm gonna plug this into Desmos at some point, but let's not use a graphing calculator yet, because you're probably not supposed to use one. So what I want to do is graph each of these components individually, and then we can add them together visually. So let's start with the absolute value of x. That just looks like a v, like that. It's like this portion is the line y equals x, this portion is the line y equals negative x. And then 1 over the absolute value of x, well, I know what I like to do for this is graph it without the absolute value and then adjust it. So just 1 over x looks like this. But if we take the absolute value of x, these negative x's are the ones that are getting affected, and these negative x's are going to turn positive. So really, this thing just gets flipped up to the top. And that's the only way that this graph will change. The big thing to notice here is that this is not defined for x equals 0. So that's something we can already delete from the range. So if we want to add these two graphs together in a third graph, well, around 0, that's the value of x is relatively small, but 1 over x is pretty dang big. So the 1 over x is going to dominate, and it's going to look more like 1 over x when we're close to 0. But then as we go further away from the origin, 1 over x drops off, and just x continues to increase. And since 1 over x is approaching 0, it's going to look more like a line, or it's going to look more like 1 over x. And to the right, 1 over x goes up and to the right. It'll look approximately linear like that. And to the left, it goes up and to the left. So I'd say this is, the idea of how x plus 1 over the absolute value of x looks. And I'm sorry, I said we can delete 0 from the range. 0 is not in the domain. I was getting my terms mixed up there. So we can see the range, it definitely goes up to positive infinity, our y values. But we need to figure out what that bottom, where it bottoms out, which I think is a calculus problem. Do you know calculus? Because I don't know of a non-calculus way to figure out this thing out. Oh, you can quadratic formula that? I'll definitely give it a try, so I can see how it works too. Take plus in the first case, negative in the second case, then use the wavy curve to get range. So yeah, this is the part where I'm not sure what your knowledge is. We can make the argument that this thing is symmetric on either side, so we can look at just one of these and figure out where the bottom is, and that'll be the bottom of our range. So just the right side here is both of these positive. And we can pretty safely assume that the minimum for the right side is the same as the minimum for the left side. The thing is, to get the minimum of this, I think you need calculus for it, and I don't know if you know calculus. I hope you do, so I don't know of another way. How would you do it, Anders? Because I can't... I can get a parabola out of that? By the definition of range? Elementary, high school... Oh, hey, I mean, that's enough. But there might be a... If it's pre-calc because you use a calculator in a lot of schools, that's fair. So whenever x is equal to a constant. I don't know where that comes from, Wheeler. Just expand it? Don't you get an extra term in the middle? And I don't know how you suddenly jump to f of x being greater than or equal to 2. So, okay, but if you don't know it, okay, let me, Kobe, you said you know elementary high school calculus. So if you have a function like this and you want to find the minimum, we can take the derivative of it. Let's just call it equal to f of x. If we take the derivative, these are both power rules where, goodbye marker, where 1 over x is the same thing as x to the negative 1. So it's a relatively simple derivative to take. X derives to 1. 1 over x derives to minus 1 over x squared. If it helps to see it, it's the same thing as negative x to negative 2, what this thing derives to. You set it equal to 0, because that's how you find a minimum or a maximum, and you solve for x. So 1 equals 1 over x squared. Flip each side, x squared equals 1. So x equals plus or minus, well, square root of 1 is 1. So the minimum occurs at x equals plus or minus 1. So we need to plug 1 into the function to figure out the value, because we want range. 1 plus 1 over 1 is 2. As was already said in chat. Oh, I don't know how they got it. So I say the range of this is 2 comma infinity. Okay, yeah, so yeah, you're able to figure out the derivative too. You said equal to 0, solve for x. Then differentiates, yeah. Solve for, oh. That's interesting, Anders. I guess you'll get into a similar thing about what SPQ got. In this case, we were only considering the x greater than 0. Like, we're not allowed to go from this absolute value function to this without the restriction x is greater than 0. So if we get a negative number, we just throw it out, basically. I bet you this minimum happens to occur at -1 as well. I wouldn't consider this a proof of it, though. Oh, yeah, no worries, Kobe. Okay, so let's look at Isaac Newton's question. Oh, shoot, I don't think links work in YouTube chat, unfortunately. But I have time now to look at Isaac Newton's question, so we can... maybe Teratar can guide me through this. And hey, Rubens, there are no 8 consecutive positive integers that can be written in the form 7x squared plus 9xy minus 5y squared. I have no clue how you do that offhand. I'm gonna work on this question that I just put up above, though, because it was asked first. So the idea that Teratar had for this problem that I want to see how it works for myself, too. So we take n squared plus 19n plus 92. We set it equal to k squared, where k is an integer. And then we solve this, we can subtract the k squared over to the other side and use the quadratic formula, apparently, where this is our c. So let's see what that looks like. 19 squared. Who doesn't know what 19 squared is on top of their head? Can I figure it out? Is there a way to do it with 20 squared? Not that I can quickly figure out. 381? Scrimp knows. Plus or minus. Oh, wait. That's minus b. B squared goes here. Oh my god. You know I'm late in the math stream when I don't know the quadratic formula. Minus b plus or minus square root of b squared minus 4ac. 4 times 92 minus k squared over 2a. That's annoying. Minus 19 plus or minus 381, 4 times 92. 360 plus 8 is 368. Is this thing gonna be a perfect square? That'd be cool. 381 minus 368, is that 13? I think so. Oh, that's not a perfect square. That's icky. Wait, 361? Oh. Scrimp, you goofed. Well, let me, okay. What is 19 squared? 361? Okay. I was impressed though, Scrimp, for what it's worth. 400 minus 19 minus 19 minus 1. Oh, how do you delete a comment? Oh, I think it's possible to retract, but I don't actually care. I'm just making fun of you. I still appreciate you being engaged and trying to help. So we get 4k squared minus 7? That's still pretty icky. We know things should be greater than 0. (100 plus 180 plus 81). So if we know n has to be an integer, we need to force this number to be an integer somehow. 4k squared minus 7. We do want the thing to be greater than or equal. Well, equals to 0 doesn't help because you don't get an integer if it equals 0. That will give you a real number solution. So all this really tells us is that k is greater than root 7 over 2, plus or minus. Oops, not. So I don't know, this piece doesn't seem to help that much. We do know, like, this should be an odd number. So that way the odd number we're adding it to or subtracting it from becomes even and the 2 divides out. Let me see what was Territar saying before? Oh, sorry, I missed a few things in chat. Oh, Rubens, you don't have to apologize for that. I haven't done a question like that before. Kobe, bro, can I ask you a personal question? I like math. Am I a nerd? Because everyone in high school calls me a nerd. I mean, I'm just a nerd and I'm proud. I think everyone's a nerd in their own way. If they're making fun of you, then they're the ones who are wrong. N equals... Oh, okay, so I got to the same place as Territar did. But surely we need to say what k is. Or is k literally any integer? Kobe, I'll take a look at that after this problem. Scrimp, you're saying the determinant must be 0. I was thinking we will get 19 over 2 if it is 0, or negative 19 over 2. Oh. N has to be an integer. But I guess the roots of that parabola don't have to be integers? Yeah, sure, Isaac. I wouldn't mind seeing what the answer is supposed to be. Okay, so yeah, Scrimp, that's a nice idea that you do get a perfect square where the discriminant is 0. Let's pursue that and see what it looks like. I know it's important to actually solve this for k. Well, does that mean n is 19 minus 19 over 2? N's supposed to be an integer. I don't know how you interpret this, I'm going to be honest. The answers are 5 and 6? What? Don't feel bad for... Oh, yeah, no, Inspix Pachinko was saying, don't feel bad for liking math or being a nerd. Those are them problems, someday they'll envy you. They're all smart, or resent you for being smart forever. Been there, done that. All of them peaked in high school. Yeah, if you like math, you just like math. You type... Oh, okay, it's the wrong question. Okay. So I'm saying -8 for n or -11. It is weird that we're trying to make k an integer, but we don't get an integer k. Well, I'm glad it gives you happiness, Joseph. Kobe, if there's multiple people asking questions, there's only so much that I can do at one time. The integral of x ln x. There's like I'm a little bit stuck on this question for now anyway, until Isaac hopefully finds the answer. I don't know. You can probably integrate it by parts, but I don't actually know that. I want to see if this is something stupid before I actually try to integrate it. Okay, that's not stupid. Integrate by parts, right? Okay, yeah. Oh, wait. Isaac, what's correct? I was saying -4, -8, -11, -15 for n. 4k squared minus 7b per square. Maybe Phobos. But yeah, Kobe, when multiple people are asking questions, I have to just switch off. There's not much else that I can do. I don't see a pattern in the answers that Fembox gets. And just saying k equals 2 works? Because you get 1 and you get n equals -9? Square. I really don't get what you do with this quadratic formula. Is that just like, did you get those just from trying values for k? Yeah, but like we need to get this like every integer that works. You completed the square. Oh. A few extraneous solutions. Do you complete the square on the original problem? Make Wolfram Alpha complete the square for me, ideally. You have to get rid of the square root for it to be a rational value. Square root must be a square so they cancel each other out. Automod on Twitch held that back for race, ethnicity, or religion. N plus 19 over 2 squared plus 7 over 4. I don't get Automod. Um, 4k squared minus 7 to be a perfect square, W. Yeah, how do we, like... I don't know how you make it perfect square aside from trying values of k. Scrimp, I don't think that form works because there's no middle term, unless you're saying to exclude the middle term. Yeah. How offensive can you get? That's pretty wild right there. Try to plug in -8 and -11 in place on n. What, equal to the same k squared? Okay, yeah, it should be a different. And that's a system of equations? Sorry, Isaac, I was looking at what's happening in Twitch chat, so... We're saying that for this to give us an integer solution, we would need 4k squared minus 7 to equal some other perfect square. That Suki is saying is j. And if you can factor it as 2k plus j times 2k minus j equals 7. So each of them individually equals 7? What? Wait. Oh, that one of them equals 7, the other one equals 1. That's the only way you can multiply integers to get 7. What am I writing? and just like solve that for k and j. K equals 2? That's super weird. And if k equals 2, you do get just 1 there. So negative 19 plus or minus 1 over 2. Minus 10? Wasn't minus 8 a thing? You get 3? I can't do math. Well, yeah, that was my greatest lie, Obi, that I'm able to do math. To 2k squared. There's too many different trains of thought. I'm lost in this problem. I don't see the error in what I did. I believe that I made an error. I'm really lost in this approach, but and I don't know how you make that completing the square thing work either. Turning back to what n equals. Yeah, so I plugged k equals 2 in. Oh, 4 times 4 is 16. That seems like a mistake. Yeah. Okay, the mistake, I thought the mistake was here. The mistake is up there. I was doing 4 times 2 because I just don't enjoy squaring numbers. It's 4 times 4, which is 16. 16 minus 7 is 9. Okay. So negative 5? And negative 14? Question mark? Oh wait, 3. Dang it! Oh my god! I was like, it's still not right. I can do like 4 out of 5 of the operations called for in this section. Not all 5 at once. Okay. Negative 8, negative 1. That's what I was supposed to get, I think. Other cases to check for, Ruben says. So, yeah, I guess we got... I assume it's that... Okay, yeah, Ruben's saying we need to check negative 1 and negative 7. Oh, that's the cleaning the square approach, Wheeler? I don't know what you do with that, but... Oh, I guess maybe you do the same thing as you do here. It's supposed to be a 1. Add them together. Well, wait. Aren't we squaring k anyway? I don't think we get anything unique from there. Do we reverse 1 and 7? Would that get us a different solution? No, wait, it's just gonna come out to be the same thing. J's are going to get the same k. Okay. Or you just get -2, which doesn't make a difference for this problem, I guess. Well, wait. Oh, well, yeah, J might be like the positive or negative version. Are there any other answers than -8 and -11? Like, did we finally get to the bottom of this question? Does Wolfram do it? There's no other solutions? Oh, okay. Oh, hey, look at that. Okay, so Isaac, I think you did a few questions. If they're like that, I mean, I'm willing to try them, but it's gonna take a minute to work through it. Kobe, are you still here? You were asking about the integral of x, ln x. And actually, before that, Ruben's. Oh yeah, no, I took a second look at it, hoping that I could try to figure it out, but I feel like I'm hopeless with that. How did you rate this question? If I wasn't 4 hours into a math stream, I probably would have done better on it. But I don't know, like how much I enjoyed it or how hard it was. What am I rating it on? Yeah, waffle. Um. Actually, I'll copy paste Ruben's question over to the Twitch chat in case someone has an idea for it. It seems really complicated though. I don't know how you'd even start it. I don't see Kobe still typing in chat. Maybe I'll still solve it quick and see if he checks the video. Also at Kobe. Kobe just wants to know the integral of x, ln x. I cheated and looked at Wolfram just to make sure I had the right idea. You want to do integration by parts here. For basically the I setup, we would take. We want to derive the ln x. We just want to get rid of it entirely. We'll integrate the x by default. du is 1 over x dx. V is 1/2 x squared. Then we do u times v minus v du. So 1/2 ln x squared over 2 ln x. Who cares? I'm saying derive. And then the reason we did integral parts with this is so we get 1 over x times 1/2 x squared. Remember to actually adjust the power though. dx. Integrating 1/2 x, you get 1/4 x squared, and don't forget your plus c. So if Kobe checks the video, that's how you do it. Graphics, wrestling, gameplay is 5 out of 10. Story 2 out of 10. Oh, on hardness, that should be like a 4, I guess. It shouldn't have been as hard as I was making it, but I'm just like getting tired. Yeah, but it's an uphill battle when I'm like frustrated from not doing math well. Hey, Neon, how's it going? Hey bot, linear algebra? I can do the very, very basics of linear algebra, like row operations, how to multiply matrices, like what does span mean? Outside of that, my linear algebra knowledge is really not good. -8 in the quadratic gives 4. Wait, we got -8 as a solution. Isaac, right? Like, it's supposed to give a perfect square if we plug in -8. Yeah, so that's what's supposed to happen. Same with the other solution we got. Oh, you get 4 again. Funny. I think it's because it's a parabola. You took over an hour on a 5-question assignment? Oh no. I've had classes like that. Oh yeah, that the drawing is from Joseph. Or requested by Joseph. Yeah, it's like is there a problem with that? That's pretty reasonable to get. You're supposed to get a perfect square. So if you want to try it and put another problem in chat, Isaac, I'll try it, but I can't promise that I'll do it well. Is that the integral from 0 to pi over 2 of tangent x times x dx? I mean, we did it without Wolfram on the board. Oh, x over tangent x. Oh. It's even worse. You don't have any good ideas in the 8 consecutive integers problem? Yeah, me neither. Yeah, we figured out how to do the integer problem. Oh, yeah, but I'm not doing that then. There's gonna be some disgusting thing. Yeah, Isaac, we figured it out without using Wolfram. I wish I didn't erase it now, but yeah, Territor, we found it's n equals -8, n equals -11. You have to do a bit more work after doing the quadratic formula, but we got there in the end. Yeah, Neon, I can't do that problem. It looks like competition math, and I just can't do it. Zach apparently figured it out, and he's gonna hopefully at you on Discord when he posts his VOD, but I don't know how to do it. I don't know SPQ. Um, oh, the book? We've been using Purcell for the reading group. It's really difficult. Griffith's probably a gentler introduction, but I really enjoy the math that we've been doing here. I haven't read Griffith's though. Oh, nice, Joseph. Yeah, we're gonna figure out the n squared plus 19 and plus 92 per problem. I guess there's a putting the square way to do it. We did a quadratic formula way, but they get to the same answer, I think. For high schoolers, unless you're some genius high schooler, I probably prefer neither. For physics Olympiad, I mean, I know nothing about the Olympiad, but I haven't read Griffiths, and I've only barely read Purcell, so I probably recommend Griffiths on the grounds that it seems to give you a lot more background information. Uh, and I've heard it's like it's the more popular like book to introduce this stuff with, so probably Griffiths, but it's not like I've read both. Oh. Taylor? I never heard of Taylor. You reduce a modulo 13? Oh, I haven't read a mechanics book. So, I know nothing but the differences between those two books. It's a great book you've heard? Oh, okay. Multiplying by the... So this is... Wheeler's putting an idea here for the problem that Ruben's posted before. I don't know if Ruben's is still here, but I'll transfer it over to the YouTube chat. So wait, dy by dx. This is just... Why do you have to take the derivative of this? Oh wait, this is this already the derivative? Like, what is this? I don't get, why is it equal to 0? Oh, transferring over some more. Dy by dx at x equals -1, like, do you have to take the derivative of this? But if you do, why is it equal to 0? This is just annoying. Oh, because it's implicitly defined? This is just tedious. Like, where is this problem from, Neon? Especially biologists? I haven't looked at, like, biology math. Do they abuse symbols? That they use Griffiths? Oh, wow. Those are some smart 11th graders who are reading Griffiths and qualifying for the physics Olympiad. I don't be able to get anywhere close to this level math in grade 11. Oh, my hair does look a lot darker than normal. I just got a haircut this morning though. Top batch students in coaching. That makes sense, yeah. Griffiths is gentler than Purcell. Yeah, that's my feeling too. Like Griffith starts off with like an entire chapter just catching you up on the vector calculus that you need. This does not. Like, there's no way this is from a normal calculus class. Like, is this a competition thing? Like, this is just a stupid problem to have to do. I'm sorry, but like, getting the implicit derivative of this. And having to plug in -1 is just a stupid amount of work. All right, see ya, Isaac. Thanks for the question. Yeah, I'm sorry, but like I'm not gonna do this problem. It's gonna take literally forever to work out all these like chain rules, and you have to do the exponentiation thing for this first one. Cybermage, I was looking at this problem, but it's way too much work. They wanted to get the implicit derivative of this, and I'm just not going to do that. It's way too much work. And if I would get x equals -1, so I'm just going to go back to studying until I just for a little bit longer, then probably wrap up stream. Hopefully you can hold out until Penn Center starts up his stream. Kind of what I'm aiming for. Shop's hair potion added pigments. I guess so, yeah. I don't know. It does look a lot different. I'm calm, Cybermage. Yeah, look how long that it takes out 4 lines, that derivative. Ugh. Look at that. Like, for each, if you don't know what it is, you need to try on the side, derive them individually. Yeah, I don't even know, like, doing the exponentiation thing with y in there is kind of weird to me. Like, I don't know how to say if that works the exact same way or not. But that's a pretty disgusting result. This problem would, like, I feel like it would easily take me an hour by hand to work all this out and correct any typos that I inevitably make. Explain the solution? Okay, that's at least a kinder thing to do, but like, this is also a lot to explain. The first thing here, it's just complicated. I'd rather come to that last. For the √3/2 arcsecant 2x, I would just look up this formula. I don't know what the derivative of it is offhand, but that one at least is going to be formulaic. You would get that, you keep the theorem true on the outside, and because of chain rule, you multiply by 2. This third term, it's annoying, but you'd have to do a product rule with the 2x, the 2 to the x, and the tangent. But the tangent is going to involve chain rule. Like, it's... These second two terms are straightforward, but a lot of work. I assume maybe the part that you don't understand as much is how to take the derivative of the first term. So this is, I think that first term, it's like conceptually difficult, but maybe not that long to do. It's sine of y to the sine of pi over 2x. We want dy dx. So for this, we'd want to do, we want to like exponentiate it. So we can say that this thing here is the same as e to the sine pi over 2x times the natural log of sine of y. So all we've done is like you can go from this step back to this step by using exponent rules. The e and the ln more or less cancel. So sine of y would come down, and that part would stay in the exponent. So these two things are completely equivalent. And I assume this we might know what to take the derivative of. The derivative of e to the something is just e to the something. But then in chain rule, we have to take the derivative of this part up here, which is a product rule. So in the product rule, I'm going to derive that first, multiply by that. The derivative of sine pi over 2x is pi over 2 cosine pi over 2x. Now when we multiply by that, same thing. And then we do plus, and then that's the other part of the product rule, we derive that, keep that the same. Sine pi over 2x over, then ln derives to 1 over whatever's on the inside, sine of y, but then chain rule, derive the inside, sine derives to cosine, and because we took the derivative of a y, we're going to multiply by dy over dx because of chain rule. I remember on the right side. This part, it just turns back into the original thing we had there. No more e. And I don't really see a way to clean up the right side, so it just stays the same, unfortunately. dy over dx. And hopefully that Does that match the solution? Oh, the solution isn't laid out very nicely for this. They get a -1 in an exponent somewhere. I don't see how that's possible. I don't see how they get the -1 in the exponent there. Oh, because of the sign y that I have on the bottom. Because of that sign of y, if you distribute the outside term in. So yeah, what I did for this first part matches the answer key. And the other two parts are going to be tedious as well, but I did the one that's more conceptually difficult because you have to do the exponentiation part. The other ones, you're going to be applying product rule and chain rule again. It's going to be just annoying. But eventually we get an expression with x's, y's, and dy's by dx's. And they don't even tell you what y is supposed to be. You're supposed to plug in x equals -1 to the original equation and figure out that y sum equals -√3/pi. But you can plug these two numbers in to this expression above, equals to 0, and solve it for dy dx, basically. And you get that monstrosity. So I'm not going to do the entire problem because I would need like 3 more whiteboards, I think, for all this writing. But I at least did the concept, like what I think is maybe the trickiest part. Yeah, it's even hard to even explain like the entire solution because it's just too many symbols to easily get around. Okay. So in physics, we've just arrived to the energies stored in a capacitor. Oh, for that piece of it? They just want to make you do a lot of work in this problem for some reason. You're given x equals -1. You have to plug it into this original thing and solve it for y. Like, you have to actually evaluate all these things for x equals -1 and then take the arc sine of it. But yeah, I'm sorry I'm not explaining it fully, but it's just too big of a problem. They only just started teaching you derivatives. I hope you weren't assigned this problem. What do you know about derivatives so far, I guess? And Dasarath, yeah, the task here was to evaluate dy by dx and figure out dy by dx at x equals -1. So we had the solution, we were kind of like going through a part of it, but it's too long a problem for me to do in full. Some extra tips. Okay, let me if I haven't linked you to it already, let me give you Paul's online notes. The Calculus 1 section is where they will go over derivatives. I love the site for all things calculus. So they talk about product and quotient rule, your common derivatives, trig functions, exponents and logs, all that stuff. Yeah, shield type, chain rule. So like we had to use implicit differentiation in that problem. And logarithmic, well, no, logarithmic differentiation is something else, right? No? Okay. It's like, when I saw that sine of y to the power of sine of pi over 2x, I treated it the same as you treat this problem, differentiating. Oh, see, Paul's on team to differentiate. Y equals x to the power of x. You have to use basically that same trick. I guess Paul shows it in a different way. But it's the same concept. Yay, Paul. So yeah, this is a really good resource. Yeah, right. That's Roth. I learned that's like the power rule is called. Like right here. X to the n is n times x to the n minus 1. Yeah, in general, just for taking the derivative of things, it's pretty procedural. Generally, taking the derivative is a lot easier than doing the opposite, which is integrating. There are some weird things that you have to get used to, though. Teach you implicit? Yeah, sure. We're going to talk about implicit differentiation. So we use it in one step up here. Or the entire problem is implicit differentiation. It only came up in one step here when I had to put the dy by dx in here. Let me show a much simpler example, though, because that's not a good introduction to implicit differentiation. It's called implicit differentiation if you have a function that is implicitly defined, which means you can't isolate y. Teach the general derivative operator. Let me actually get an example that Paul gives, and let me work through that so I don't have to think of one on top of my head. So the entire idea of implicit differentiation is it's helpful for, well, there you can isolate y, but you don't have to. Or we often use it when it's not possible to isolate y. Like here, you technically can isolate y, but you get like a weird plus or minus a square root situation. So let's take the function in this form and differentiate it implicitly. I need to switch out the ink in this blue marker. S squared plus y squared equals 9. It's just a circle. So if you wanted to, you could subtract the x squared over and take the square root of each side. But you run into the weird issue with having a plus or minus there, and how do you take the derivative of that? So like you probably can figure something out, but it's a little more straightforward to me if we just use implicit differentiation. So we're just going to take this original equation and find dy by dx. That's the thing we're really interested in. So we're going to take the dy by we're going to take dy by dx of each side. x squared plus y squared equals dy by dx of 9. Okay, so let's distribute the dy by dx into each of those terms. And 9 derives to 0. So the derivative of x squared, you probably already know, or you hope you already know, is just 2x. Is this really... I'm sorry. I think I'm slightly wrong. We're doing just d by dx. What the derivative in terms of x? I'm sorry. This is right now. Yeah, thank you, Fembox. Oh, sorry. Was there something loud? So yeah, we're in middle stick. We're doing the derivative of x, which is just d by dx. I was inserting the y because I was thinking ahead to the next step, but we're doing the derivative of x. So d by dx of x squared is just 2x. But d by dx of y, or y is a function of x. So it works. We're still allowed to take the derivative of y in terms of x because y is a function of x. It's a little bit weird though. We can still apply our power rule to this y squared, so it'll still be 2y. But because of the chain rule, y has some type, like y has like some x's like hidden inside of it, basically, and we need to worry about the chain rule. So in case y, we need to basically multiply a term here for whatever we would get from the chain rule, and that term is dy by dx. And that's what I was getting mixed up before with having dy dx before. So this dy by dx represents whatever we would get from the chain rule from differentiating y. And now from this, their task is to figure out what dy by dx is. So all we have to do now is isolate dy by dx. So subtract the 2x over to the other side, and then divide by 2y minus x over y. So that's the slope of the tangent at any given x, y, or like, you know, at any given point x comma y. You could, in theory, do the same thing again with like figuring out what y is in terms of x and plugging it into this. We still get that weird plus or minus thing to deal with. So you usually call that your answer? Oh, the derive was for 2 dy dx. Did I make a mistake? The derive. Oh wait, are you making a joke, or did the mic actually peak? Or like, was the microphone actually, like, was there a tech issue there? I don't know if you're making a joke or not, sorry. Okay. Sorry, when I hear about potential audio issue, I get like PTSD from my OBS audio issues. Have you seen a formal proof about how typical associativity axiom? Ooh. Wait, let me verify the answer. Okay, so I did get to the... Paul gives it as y prime instead of dy by dx, but it's the same thing. You do end up with minus x over y. The general kind of... If you want just something to memorize here, rather than the concept, if you need to take the derivative of something with y in it, you can use the exact same rules as if it was x, just remember to multiply it by dy by dx. So anytime you take the derivative of a y, multiply in that dy by dx, but otherwise you can pretend like it's an x. That's kind of like the takeaway for implicit differentiation, for me at least. Let me read what Anders put a bit closer. A formal proof about how the typical associativity axiom with 3 elements implies. Oh. That's something that, like, and see, I think what Andrew's asking about is extending that property to be for A, B, C, D, E, F, G for, you know, an arbitrary number of letters. But yeah, I hope that makes sense. In Dasarath, you're noob in differentiation, 11th grade, still learning? Oh, I mean, I didn't learn about differentiation in 11th grade, so you're doing better than I was. I highly recommend you check out that same Puzzle Line Notes site that I linked before. But if you have any questions, that's something I can definitely like help with. Induction seems unavoidable. I don't know how you to my applied math brain, I would say it's obvious why even bother, but it's kind of against the spirit of why you would want to prove that. Well, let me try just like Googling, because I know I'm not going to be able to do it for myself. Extending associativity with 3 elements to more elements. We can do integration in 9th grade? Wow. Yeah, that's a lot earlier than most Americans learn it. Yeah, we're just talking about implicit differentiation. Okay, this looks like the same question. Let's see what answers it gets. Oh, induction. Oh, what the heck is this? Oh, okay. I've had Penn Center's Discord open. I think he just went live. I'll probably gonna wrap things up in a second here. Anyway, Dasarath, let's see. We're gonna understand what's happening here. Actually, I mean, this is induction. Andrew said he wants to avoid induction. Let's... Is there an alternate? Ooh, color coding. I never see that on Stack Exchange. This is still induction, but it's a little more intuitive looking, I think. Yeah, Phobos. Huh. Okay, everyone likes induction here. Oh, geometric proof. Okay. Parenthesizings? Oh, God. Wow. Discriminants, resultants, and multidimensional determinants. Just sounds smart. All the ints. Oh my god. Okay, I'll drop the link to this thing in chat, but I think I want to wrap things up for the day. Let me just make sure that Penn Center did indeed start stream up. Oh wait, I don't actually see him in my list. Why did the Discord message go out? Catalan members pop up. Oh, really? Oh wait, is Penn Center not actually live? No. Okay, fine. I guess we'll keep on stretching it. Maybe he's about to go live. In the meantime, I guess we'll go back to physics. I mean, we can keep on reading this, but like I don't think I'm going to be able to understand any of these proofs. That looks cool though. Stasheff polytopes. On a related and more ridiculous note, existence of a permutohedron? What the hell? That's the word of the day, permutohedron. Q equals Q phi over 2. Wow, that's really elegant. Wow, what the hell? That's so weird how that it makes sense, but like it gets that weird 1/2 factor as well. Huh. Exact same formula. It should be the exact same. Just crazy how the same thing pops up from a different context, I guess. Is Penn Center live yet? Still not? Alright. The class is starting in like a couple of minutes, so we should be live. Which we were fighting last Saturday. The energy one? Oh, true. Yeah. Or, it's similar at least. Wait. Bro. Maybe it is. I don't know. Oh, pass over in YouTube chat. If A, B, and C are in AP, and if PQ are in HP, I don't know what AP, HP, or GP mean. Yeah, okay, was that one where you figured out the idea with like the infinitely large Gaussian surface? Wasn't that I guess it was. Yeah, it probably was. Um, yeah, possible. I don't know what AP, HP, or GP mean in that. Arithmetic, oh, and harmonic. Here I'll copy the entire question over. I probably can't do this, but maybe someone else knows. What is harmonic progression? Is that? I assume it's related to like the harmonic series. Or sequence, same thing. P over R plus R over P. I definitely don't know how you would do this offhand, but I would need someone in chat to like know how to do it, and ideally in the next few minutes. Oops, sorry. Got an ad. It seemed what do you mean by a quadratic? If it's anything like that last question, I have never done like that type of math. And if it's from a competition, I can guarantee that I'm not gonna be able to do it. But I'm gonna wrap the stream in a few minutes here, so if anything you want to try on me, then do it quick. Ideally, because I don't want to go for much longer. Squared. Okay, yeah, I don't know how to do that. I'm sorry, pasta. I'm better with like calculus type questions. The points of discontinuity. I'm sorry, Dasrath. I think I'd be able to work that one out, but I'm just gonna wrap the stream up for the day here. You basically want to find the number of integers that 2 cosine x crosses over. It should be find the points of discontinuity. Or oh yeah, it'll be wherever it crosses from one integer to the next one, but I'm not gonna be able to work it out like quickly, so I'm just gonna wrap things up. Because I've been streaming for 5 hours and I'm starting to not be able to think. If you want to try me another day, I should be able to work it out, but I'm sorry. But yeah, I'm gonna wrap up the YouTube stream here, so for everyone here on YouTube, I appreciate you. Back on YouTube on Saturday. I'll start off with the physics reading group on Saturday, but after 2 hours, I'll switch back to doing normal math. Not today, Dasaroth, but another time, yeah. So yeah, goodbye, YouTube.